All right, hey guys. Today we're going to talk about graphing rational functions. All right, and we're going to spend quite a few days going over this, practicing it before we're going to be assessed on it. All right, so for each problem that we are going to have to graph, you're going to have to answer 5 questions. All right, before we even graph anything. All right, first we're going to want to be able to find what the vertical asymptote is. Then we're going to talk about horizontal and slant asymptotes. Then we're going to talk about x-intercepts. Then we're going to talk about y-intercepts. And then we're going to talk about symmetry. So for each problem, we're going to have to answer these questions first before we even graph it. But once we solve these, that's going to make the graph real easy. All right, so I'm going to briefly just talk about what each of these things are. It'd be a good idea to write these down in your notebook. So that you guys can refer back to them. And then we're going to go through a couple of examples where, obviously refer back to this, to these notes to help you solve each thing before you have to graph. All right. Now, VA here, that stands for vertical asymptote. And as we talked about in the previous 2 lessons, all right, vertical asymptote, we are going to set the denominator equal to 0 and solve. All right. So whatever makes the denominator equal 0, if I had an equation that was 2 over x plus 3. That means my vertical asymptote would be at x equals negative 3. All right. The reason I have this x equals a number, you don't just want to write down negative 3. It's got to be x equals negative 3. There can be more than one vertical asymptote, like you guys saw in the previous assignment. All right. Then I'm going to skip this for 1 second. I'm going to drop down to 3, which is an x-intercept. All right, to get the x-intercept, you're going to set the top equal to 0 and solve. All right, so for example, if I had y equals x plus 1 over x minus 3. All right, what value, you would set x plus 1 equal to 0. So that means negative 1 makes the top equal to 0. So my x-intercept for that example would be negative 1, comma 0. You write it as a point. Do not just write negative 1. So it's always going to be some number, whatever you get to equal 0, comma 0. All right, that's how you write an x-intercept. There might be a problem where there is no x-intercept. For example, if we look up here, if this was our function, what makes the top equal to 0? Nothing. There's no x up there. 2 can never equal 0. So it is possible to have no x-intercepts. It's also possible to have more than one x-intercept. All right, so x-intercepts, you set the top equal to 0 and solve. Y-intercepts, you plug in 0 for x, and then you simplify. All right, so for example, if we use the same problem, if I plugged in 0 here and I plugged in 0 here, I would get 1 over negative 3. So my y-intercept would be 0, comma, negative 1/3. Right? 0, comma, negative 1/3. It's all, once again, it's a point, and it's always giving me the form of 0, comma, some number. All right. There might not be a y-intercept. All right. It is possible that you cannot have a y-intercept, but you cannot have more than one y-intercept. It's either one or none. All right. And then the last one they'll ask you to do is symmetry. All right. Symmetry is either even, odd, or it can be none of them. All right. To be even is when a graph is symmetrical about the y-axis, which basically means that if you had something like this and you had a perfect little this and this, and it's reflected over the y-axis. If I folded this over the y-axis, it's the same graph. That would be even symmetry. All right. Odd symmetry is if it's symmetric about the origin, meaning if I had something like here and here, and if I rotated this graph 180 degrees, I would get the same graph. This would go here 180 degrees, you get the same thing. And once we start doing examples, you'll start to pick up on symmetry. You're really not going to tell until after you graph. These first 4 things you're going to be able to tell before you graph it. Symmetry, you're going to wait until after. All right. Now, this number 2 here, the horizontal, HA stands for horizontal asymptote. SA stands for slant asymptote and a hole. All right. for right now, we're only going to worry about the horizontal asymptote because there's 3 different cases: case 1, 2, and 3. 3 we're going to deal with tomorrow. All right, and that's where we're going to get the slant asymptotes and the holes involved. All right, but our first 2 cases, which we're going to deal with today, that's where we're going to have a horizontal asymptote. All right, so our first case is whenever we're doing horizontal asymptotes, we look at the degree. The degree is the highest exponent on the top and the highest exponent on the bottom. So that's what we're looking at. We're looking at what the highest exponent is. Whenever the degree is larger on the bottom, for instance, y equals x plus 1 over, oops, don't know why that didn't work, x plus 1, there we go, over x squared minus 4. All right, so the degree on the top is 1. The degree on the bottom is 2. The degree on the bottom is larger, so whenever that happens, automatically the horizontal asymptote is always y equals 0. It doesn't matter what else is in the problem, you only look at the degree. The horizontal asymptote is y equals 0. All right? Now, with vertical asymptotes, you can never, ever, ever cross a vertical asymptote. With the horizontal, there are exceptions where you will cross it, but it always happens around the origin, very, very close to the origin. As you go to infinity, the horizontal asymptotes, the graph approaches them. And we'll see a bunch of examples. Like I said, we're going to be doing this for like 3 days, so you're going to get a lot of practice with this. All right, so the degree is larger on the bottom, it's going to be y equals 0. Case 2 is going to be if the degree is the same on the top and bottom. All right, so if I looked at this example that we had previously done, y equals x plus 1 over x minus 3. The degree on the top is 1. The degree on the bottom is 1. All right, so what you do is you look at the leading coefficients. It means you look at the terms that have the highest exponent. What's the coefficient of the top? It's 1. Over, what's the coefficient here? 1. Which means my horizontal asymptote would be y equals 1. If I had 2x plus 3 in the bottom, then the leading coefficients would be 1 over 2. So then my horizontal asymptote would be y equals a half. It is always y equals. You just can't write 0. You can't just write a half. You have to write y equals, just like you did with a vertical asymptote. All right. So you're probably like, this seems really confusing, Mr. Garn, and it probably does right now, but we're now going to go through a couple of examples and then refer back to these notes. All right. If you haven't written these down yet, pause the video, write them all down. All right. And then now we're going to go through a couple of examples. All right. So now we have some examples here. Now, this is exactly how you're going to see everything. This is how you're going to see the problem set up. All right. You're going to see the function. You're going to see VA for vertical, HA. Now, what's noticed you're missing is what's originally you're going to see, and after this is going to see an SA and a hole. But since we're not doing those today, I don't have them written here. And then x-intercept and y-intercept, and then we don't have it written here, but we will need to find it will be on your homework, the symmetry. All right, so we're just going to do, before we worry about graphing, we're going to worry about this. All right, so first thing, vertical asymptote. We are going to set the bottom equal to 0. So you set x plus 2 equals 0, and hopefully everyone realizes that that should be negative 2. All right, so I get x equals negative 2. All right, vertical asymptote done. Now, horizontal asymptote. All right, so horizontal asymptote, remember from what we talked about on the previous page, all right, that you have to look at the degree. If there is no x, the degree is 0. There is none. So the degree on the bottom is 1. The degree on the top is 0, which means the degree on the bottom is larger. Anytime the degree is bigger on the bottom, the horizontal asymptote is always 0. So I get y equals 0. All right. Now, x-intercept. All right, if you look back at your notes, it says for the x-intercept, you set the top equal to 0. Well, is 1 ever going to equal 0? No. All right, which means there is no x-intercept. All right, there is no x-intercept. All right, now for y-intercept, you plug in 0 for x and then simplify, which you get 1/2, right? If I plug in 0, I get 1/2. So that means my y-intercept is always 0, comma, whatever it is. So in this case, it is 1/2. All right, so y-intercept is 0, comma, 1/2. Symmetry, we are going to wait until after we graph, all right, to figure that out. All right. All right, so now we graph and we're going to use all of this information. So the first thing we are going to do is graph the the vertical asymptote. So there's -1, there's -2. I'm going to put dotted lines is how we do your asymptote. Okay. Then we're going to do a horizontal asymptote, y equals 0. So that's along the x-axis here. So it's right along the axis. All right. Then we're going to graph any points. We don't have an x-intercept, so we just have to worry about a y-intercept. So if that's 1, all right, our point is going to be like right there, all right? And that is 0, comma, 1/2, all right? That's 0, comma, 1/2. Now, once you get the hang of graphing this, it's really easy, all right? So the basic shape, all right, the basic shape of a rational graph, all right, the basic shape of a graph. So we're going to leave this here for right now, all right? All right, so if I were just to look at y equals 1/x, that is a rational function, okay? If I were just to look what this looks like, if I were to make a little, let's say, t-chart to figure out what the graph looks like, all right? So I have, if I plugged in, obviously 0, there's a vertical asymptote right here, right? There's also a horizontal asymptote at 0. Why is there a horizontal asymptote at 0? Because the degree is larger on the bottom. So when I plug in, let's say 1, 1/1 is 1. So that means like 1, 1, different color here. I get a point right here. If I plug in, let's say I plug in 2. If I plug in 2, I get 1/2, which is like here, right? If I were to plug in, let's say, 1/2, all right, what is 1 divided by 1/2? Well, it's actually 2, which means it's like this. So what happens is the graph looks like that there. Right? On the other side, if I did the same thing, if I plugged in -1, I would get -1. So -1 is right here. If I plugged in -2, I would get -1/2, which is here. If I plugged in -1/2, I would get -2, which is here. So the graph looks like this. All right. You always have one curve on each side of a vertical asymptote. You can't have something down here because then it's not a function. It doesn't pass the vertical line test. All right. Then when I come on this side, same thing here. It can't be up here. It has to either be in one of the quadrants. So what you'll notice is when we're graphing these, and if you have a vertical asymptote and a horizontal asymptote, there's going to be a curve in one quadrant or one of the 2 of the 4 quadrants. Like here's 1, 2, 3, and 4. If it's in this one, it can't be in this one. All right. It's either the top or the bottom, right? And I'll show you a second how you're going to figure out. So this is the basic shape. So that's kind of what our graph is going to look like here. Now, it's not always in upper right, lower left. We might have to move it around. All right. So going back to this first example, since I know I have a point there, that's where I have to have this first curve. All right. So it's going to look, this is not exact, but it's going to look something like that and just show it going through the point. Now, I don't know where this other one's going to be. All right, you might be able to guess that if it's like this, it's going to be in the bottom one, but I'm not sure. The way to tell, very simple. All right, I know I need a curve to the left of -2, somewhere over here. It's either here or here. So plug in, let's say -3. All right, if I plug in -3, I get 1 over -3 plus 2, which is 1 over -1, which is -1. So -1, -3, -1, that point's down here somewhere. which means I have to have a curve that goes through it. All right, so it has to look like that. You don't need to graph that point. You could have tested -5 and gotten 1 over -3, which is -1/3, which is in here. You just check to see where it is and draw a rough sketch. Notice how these curves approach each of the asymptotes. They don't cross them. They just get closer and closer. All right. So that is the problem for number 1. Now, I don't want to forget about the symmetry. This symmetry, if I flipped it over the y-axis, it's not the same graph. If I rotate it, it's not going to end up being the same graph. So this symmetry is none. All right. When in doubt, probably the answer is none. You'll tell if it's symmetric or not. All right. This symmetry right here is odd, and y equals 1 over x. All right. All right. So there's number 1. All right. Like I said, the more we do of this, the better you're going to get. Don't be freaking out now if you're like, oh my God, what am I talking about right now? It will get better, I promise. All right, so let's look at the second one. All right, and we have 5 plus 2x over 1 plus x. So you're just going to go through step by step, same thing every time. First, vertical asymptote. Set the bottom equal to 0. That's going to be x equals -1. All right, horizontal asymptote, we look at the degree. The degree on the top is 1. The degree on the bottom is 1. They are the same, which means we take the leading coefficient. All right, we take the leading coefficient of each of them. So in this problem, it's 2x over x. We take them, it's 2 over 1. So that means the horizontal asymptote is y equals 2. All right, x-intercept, we do 5, the top equal to 0. So it's 5 plus 2x. We set that equal to 0. And we end up with 2x equals -5. Divide by 2. So we get -5 halves. Do not just write -5 halves. It's -5 halves, comma, 0. You write it as a point. Right? To get symmetry. All right, to get symmetry, you plug in 0 here and 0 here. So, I'm sorry, not symmetry. What am I talking about? To get y-intercept, you plug 0 there and 0 there. So that's gone. So it's 5 over 1, which is 5. So it's 0, comma, 5. All right, so we have all 4 of those things. We will talk about symmetry, but that's after we graph. All right. So x equals -1, y equals 2, -5 halves, comma 0, 0, 5. All right, all of that comes directly from our note sheet. You always use the same way to find all those things all the time. All right, so now we are going to graph this, all right, and we're just going to go step by step of graph each individual thing. So y equals -1. There's -1. X equals -1. Vertical asymptote is there. All right, horizontal asymptote is at y equals 2, which is there. All right, so before we even graph any other points, once again, we have a vertical asymptote and a horizontal asymptote. When this happens, we are going to have a curve on the right-hand side of this vertical asymptote and the left-hand side. It's either going to be a curve in the upper right or the lower right, and then we'll have only one of those. And then on the left, it's either going to be in the upper left or the lower left. All right. Now, I have 2 points here. Those are going to help me figure out what part of the graph I'm going to graph it. If I don't have these, then I'm going to plug in some points and see where they go. All right. So I do have a x-intercept that is at -5 halves, which is -2.5, which is less than -1. So it's over here, which means I'm going to have a curve that's over there. My y-intercept is at 0, 5, which is up here. So since I have a point in this quadrant, it makes it real easy. I know there is a graph, curve has to be up there, and there has to be a curve down there. All right, and you would just label those points. All right, and there's your graph. We have the 2 curves. They will not always be in the upper right and lower left. There will be things that change. There'll be sometimes they're both in the upper. All right. All right. Now, symmetry-wise, whenever you have a vertical asymptote that's not at x equals 0, you're probably not going to have symmetry. If we reflect this, it's not odd. You might think, well, I get the same thing. Well, no, you really don't get the same thing here. All right, so this symmetry is none. All right, there is no symmetry here. All right, so for each of these problems, we went through, found the vertical asymptote, horizontal asymptote, x-intercept, y-intercept. We then graph it, all right? And there's going to be curves in different things there, all right? Now, you're like I said before, it's not always going to be here, all right? Just to show you something, if I had y equals 1 over x squared, and I were to graph that, all right? The vertical asymptote would be at 0, right? Vertical asymptote would be at 0. My horizontal asymptote would be at 0. All right, if I plugged in 1, right, I would get 1 over 1, which is 1. So I'd have a graph that looks like this because that's where I have the points. What happens if I plugged in -1? Well, -1 squared is also a positive 1. So I would have a point here. So I have both up. All right, so there's an example. They're not always going to be opposite each other. You do have to check. All right, you do have to check. All right. All right, so we're going to do one more example. All right, we are going to do this example 4. All right, this one is going to be a little different because you'll see as soon as we do the vertical asymptote, we're going to have 2 vertical asymptotes. All right, so we're just going to try this one out, and that will be it for today. All right, so for this last one that we will do today, all right, go through the same steps. Vertical asymptote is going to be set the bottom equal to 0. All right, so I get x equals, now remember, this is, if you factored it, x minus 3, x plus 3, which means I have 2 answers. It's positive 3 and negative 3. What you can do is just write x equals plus or minus 3. Right? Do not forget, though, that there's 2 of them. So x equals plus or minus 3. Horizontal asymptote, degree on top, 2. Degree on the bottom, 2. They are the same, which means you take the leading coefficients of each of them and simplify them. Leading coefficient at the top is 1. Leading coefficient at the bottom is 1. So I get 1 over 1, which is 1. So horizontal asymptote, y equals 1. X-intercept, set the top equal to 0. Well, x squared equals 0 is 0. So 0, 0. Y-intercept, plug in 0 for x, top and bottom. You get 0 over -9, which is 0. Now, if the x-intercept is 0, 0, the y-intercept will always be 0, 0. All right? We'll find symmetry in a second. All right. So let's go through, and once we have all of those, now we just have to graph each of them. So I got a horizontal asymptote. Why do I keep saying that? Vertical asymptote at x equals 3. I have a vertical asymptote at x equals -3. And now I have a horizontal asymptote at y equals 1. Okay. So now this is different because I have 2 vertical asymptotes. Like the previous problems, though, I need to have a curve on every side. All right, so the ends are going to look like we've had before. There's going to be a curve either on the top right or bottom right, top left, bottom left, and there's going to be something either up here or down here. Now, let's graph the other points that we are given. So I know I have, unfortunately, it's only 1 point right here. Okay. Now, what's going to happen is we have to go towards these vertical asymptotes. Most likely, normally, told you guys before, you cannot cross a horizontal asymptote only around the origin. So most likely, we're going to have something that's pointing down right here. Probably going to be going down towards the asymptote. But if you want, just plug in 1. If I were to plug in 1 into here, I would get 1 over 1 minus 8, which is -8, which is -1/8, which means the point is down here somewhere. We are going to be going down this way. If I got a positive 1/8, I'd be going that way. All right. If I plug in -1, I get the same exact thing because both of these are squared. So I get a negative number, which the point is down here somewhere, which means I'm going to be going down like this. Okay. Now, to get these other 2 points, the other 2 curves, it's either going to be up here or down here. Could just plug in 4 because it's to the right of 3. I get 16 over 4 squared 16 minus 9 is 7. 16 sevenths is like a little over 2, which is up here somewhere, which means my curve is up here. Now, here's the trick. Since this curve's here, when you have 2 vertical asymptotes like this, if you have a curve here, you're never going to have a curve on the bottom. It's always the opposite of it. So if it's on the bottom, it's on the top. So for this one, I would be willing to bet a lot of money that since the curve is down here, I can't have one on the bottom. It should be on the top. But to check, we can just plug in -4. When I plug in -4, 4 squared is 16. -4 squared minus 9 is 7. You get 16 sevenths, which is up here somewhere. And there is my answer. All right. Now, hopefully someone's like, oh, this looks like this is symmetric. Look what happens. If I were to fold this over the y-axis, you would get the exact same problem. This is even symmetry. All right. This is even symmetry. All right. And we're going to do a lot more examples with 2 vertical asymptotes. All right. I know this was a lot. It's a long video. I appreciate you guys watching it. We are going to spend a lot of time practicing this. So do your best with the homework assignment, which is just going to be like 6 of these problems to try. All right. There's another separate worksheet. We'll go through it. I'll post the answer key later on. And any questions, specific questions you have, you guys can always contact me, email me, send me through Classroom, whatever you want to do. And we'll figure it out. All right. Hope all is well. Stay healthy. Talk to you guys later.